So in this video, I'm going to go through how to create a reverse shell in Python 3.12. And there's no payload because normally in hacking terms, the payload is delivered after you have a stager and it's hidden. But in this case, we're just going to have a stager that directly runs commands on the client. Normally, hacking into someone's device involves gaining command line access. But the problem with doing this by just sending a connection to the client is that there's firewalls that block these connections. If you initiate the request from the client instead, you're more likely to succeed, as firewalls are less stringent on connections coming from the client to the server. A reverse shell is a script that runs when the client downloads a file from the internet. The client sends the first request, then receives commands from the server to run, and it is run by the script that the client has downloaded. We need a way to send commands from the server to the client and a way for the client to connect to the server. To do that, we're going to use WebSockets, a pretty common protocol for communication between clients and servers. And the advantage of WebSockets over something like HTTP is that WebSockets can maintain connections, and after the client has sent the first request, the server can then send requests to the client. Unlike HTTP requests, where it's the client sends a request, then the server responds, then the server can't send any more responses. You might have noticed that this WebSockets is showing up in warning because apparently the import could not be resolved. That just means that we haven't actually installed this framework. Now, we could install it globally with just pip3 install WebSockets, but this is never good practice because what if you have two different projects that require different versions of WebSockets, right? With the global install, there's no way to manage that. Instead, we'll create a local environment. So this being the package venv and this being the name of the folder. In fact, just to make a point, I'll just call this venv2 instead, right? Oh, I spelled it wrong. Folder is going to be called venv2. As long as this is venv, you can call this anything. Then to activate our virtual environment, so that we're actually using it. Oh, yes. Because the folder is now called venv2. And you see, it runs this script whenever we run this command. Now we're actually using the virtual environment and we can install WebSockets and it will just remain locally installed within this environment. So if we restart our Visual Studio Code, we see that the errors for the import of WebSockets is gone. The virtual environment is currently activated. So let's just walk through what this quick start code is actually doing. It takes an input from the terminal, sends it to the server at this address, awaits the response and prints it out. For the server, it's the opposite. We serve it on localhost at port 8765. We wait for a request from the client, we print it out, and then we send back a greeting, which the client receives in this line. Right? What we want to do is to take the input from the server instead, send to the client, run a command, get the output of that command. And what I mean by output is, say I typed ls, I would want the output to be the contents of the current directory. Then we would send the output back to the server to simulate a shell environment. But first, in pseudocode, we don't need this. We don't need to wait for a response from the client. We just send them commands. So this is right. Send command client on the client side. Oh, wait. First step is to get input from terminal. Send the command to the client. On the client, we don't need to send this yet. We first wait for a command from the server. Run command, and then send output of command to server. Right. So we store the input from the user. Input and a prompt. Simulate a bash shell. So I'm just going to do this manually. Then we send the command to the client, right? And it's not so hard. Just do, because this is synchronous, we await. Let's look at send command. Client side, we await the command. Then we actually run it. I'm going to use sub process for this. And we want the output of sub process. To do that, we need to configure some arguments. The first argument is capture output, which we definitely want to do. Otherwise, we don't get the output in this variable. Second thing is shell to true to simulate a shell environment so that our output actually looks like what it would look like if we had a real shell on the client itself. As in we were running commands just on the terminal of the client. And we send the output to the server. So get the standard output and we decode it because it's in bytes. After running the code, we should get a string, which we then receive on the server. So I forgot this part. Print output And that's all good. Let's run this. Bad. And I just realized that I did not close down the server on the other VS Code window I was using to test out my code. But now if we do run the same command, it should work. And let's try send something. ls. We get the contents of the current directory. But you might have noticed a problem, which is that the client script exits after receiving the first command, which we don't want. We want to be able to send commands indefinitely. So what we'll do is instead of exiting at this point, await WebSocket.send, then after we just exit this. We don't want that. We want to have an infinite while loop. Which, by the way, will not destroy your program because of this await statement. All this code after the await statement can't run until we get our command from the server, meaning that the next iteration of the while loop doesn't run either. We're just stuck here, safe and sound, not triggering infinite while loops in quick succession. On the server side, we need to do the same thing. And this should work like a charm. Every ls cd into, say, bem2, then ls again. See, we're able to run multiple commands. But you see a problem, which is that even though we've changed directories, we're still getting the contents of the previous directory. Why is this happening? Well, if you look at this client script, especially line 17, we call subprocess.run, which creates a new cell session. And there's actually no way around this. I've looked online, and it's pretty difficult to get a continuous shell session on Bash. The way we can work around this is to store an array of commands on the server side, and then just run the entire array every time. So that's exactly what we'll do. We'll create a function for doing that. So we will need to pass our commands into semicolon separated commands. We'll have a list of commands, and we'll need to separate each with a semicolon. Here, instead of just getting the last input, we have a commands list array, which we need to initialize. Then send past commands list. Also, we need to return the string from the function. Yep. Let's try this one out. And we do, in fact, get the contents of the current directory, but we also get the contents of the previous directory. The reason that is happening is because our command list is going to look like this, right? ls, cd, bev2, and ls. And this first ls is going to return the contents of the root directory. Now, to work around this, you might think that how about we just get rid of all these previous commands? But that would be a problem because that would just put us back to where we started, where we were only able to run one command at a time. We wouldn't be able to account for changes in directory. Luckily, there's actually quite a simple fix to this, which is we filter out all the previous commands unless it's a change directory command. So we'll make some modifications to our pass commands function. We will have a filtered list of commands. Then we'll iterate through our commands list and filter out everything that is not a change directory command. Oh, I guess you can do this, but actually a simpler way I realized is just to only append to the filtered list when we have cd in our command. And we need to make sure that if our last command is ls, we still run that. So if, actually, let me just do it the simple way first, show you guys why. Well, we can't just do this because what if cd was our last command? We would be appending it twice, once here, once here. So we need to account for that. Cool. Let's give this a whirl. And we get the contents of the current directory, just like we would in a real bash session. So in summary, we created a shell session with our localhost server. If anyone on our local area network downloaded client.py, we would be able to access the file system by running server pi. But this approach doesn't apply to users who aren't on our local area network and aren't connected to the same Wi-Fi. So the next step is to make our server available on the internet so that any client that downloads our client.py file is compromised, and so that we can access their file system.